Hey guys, so lots of people have asked me to do solutions for the extended response of exam 2 for methods. Here it is. Haven't done it or seen it or don't know. Well, actually, all I've heard about it is people whinge and say that it was really hard as well. And it was hard to get done in the time. So, I think it's time we have a crack at it. Yeah. How many questions is it? Could have looked at the front of the paper, I suppose. 5. That generally means it is pretty long. Alright, so first we have a function which is defined from negative infinity to infinity. It has a coefficient a. That makes sense. There's a turning point at -2 and another turning point at 2. Show that a is equal to 4. So we know when x equals 0, y is equal to 4. Now I'm just going to close all the other ups that I've got, because generally it slows down the down the calculator. Okay, so we get 4 is equal to a, x minus 2 squared, x plus 2 squared. That's going to give me 16a is equal to 4. So a is equal to 1/4. F of x in that form, so it's just been expanded. So let's say 1/4. X minus 2 squared, x plus 2 squared. Now, because I haven't had reading time, I don't know whether it's worthwhile defining it or not, but if we expand it, x to the power of 4 and 4, was minus 2x squared, I think, and plus 4. Part of the graph of the function of f is we'll write down f dash of x in terms of x. It's not rocket science. Just being lazy by using the cas. X cubed minus 4x. Find the minimum value of the graph of f dash of x on the interval 0 to 2. So we can say f min from 0 to 2. The minimum value of 0 when x equals 2. Did I use f max? What did I do there? Hang on. Oh, that's f dash of x. Find the minimum value of the graph of f dash. So we've got to find the minimum of the derivative. So we know that's the derivative, and we want to find the minimum between 0 and 2. So this is another thing VCAA are not supposed to do. It's the second derivative. So we know f double dash of x equals 0 between, because we know it's a minimum, between 0 and 2. Doesn't ask for the x value, but we'll do it anyway. X equals 2 root 3 on 3. The min, I think it was negative 16 root 3 on 3. Oh, was it on 9? That's on 9. So that's that value there, and that's when the minimum value of the derivative graph. Okay, the graph of the same function, but the function that's been reflected in the x-axis and translated up to. Okay, so we can say it's reflected in the x-axis, translated 2 units in the positive y direction. Okay, state the values for which the graph of f of and h of x intersect. So we know this graph, this graph. If I paste it, make it negative, and translate it up to, I'm going to call it g of x because it's easier. If we let g of x equal f of x, and we solve for x is equal to plus or minus root 2, plus or minus root 6, I think it was. Yeah. Write down a definite interval, get the total area across the shaded regions of the graph. We know it's symmetric, so we can just find one area and then multiply it by 2. So we'll say from root 2 to root 6 of h of x minus f of x dx, because h of x is higher on the domain, f of x is lower. Find the total area of the shaded regions above. Go. Give your answer correct to 2 decimal places. So we can say the integral from root 2 to root 6 of our higher graph minus our lower graph, multiply it by 2, but I think we wanted it to a number of decimal places, 2.721. 2.72. Do we know what the units are? Let's just say unit squared. Let d be the vertical distance between the two graphs. Find all the values of d for which find all the values of x for which d is at most 2 units. So we want the distance between these to be less than 2 units. So let's say d is, it doesn't really matter, but we can do h of x minus f of x, and we want the magnitude of that to be less than 2, but we don't have magnitude in methods, so let's just say h of x minus f of x so that's the function for the distance, and we want the distance between the graphs to be between -2 and 2. So we can find, it's obviously 2 at that point and that point, so it can be 2, but we need to find these intersection points between that graph and the green graph. So we know that point of intersection is -2.61. X is between -2.61 and 1.08, negative 1.0. And we know by symmetry, it's also between 1.08 and 2.61. Oh, nice. First question done. Okay, an area of parkland on a river running through it as shown below. The river is shown shaded. The north bank is that. Okay, so let's clear whatever we've got in our CAS. What was it? 20 cos pi x on 100, was it? On 100 plus 40. Define that as our top graph, f of x. And I'm pretty sure the other one is the same thing but plus 30. It's just been translated down 10. So once again, we'll call that g of x. I always like to sketch them to make sure that they're correct. So we know that our domain is from 0 to 200 and our range is from 0 to 40 plus or minus 20. So let's just go to 70. Actually, I should do it the same as whatever the graph is. What was the graph? 80. So just go to 80. Okay, so we can see they're the same graphs. The swimmer swims north from the point P, which is at the point 50, 30. So they swim north. Find the distance in meters that the swimmer needs to swim to get to the north bank of the river. Well, the distance is just going to be 10 meters because we know they're 10 meters apart. Swimmer swims east from the point P. Find the distance in meters that the swimmer needs to swim to get to the north bank of the river. So we know here, this value here is 30. So we need to know when this graph is equal to 30. So we say f1 of x equals 30. So make sure your calculator is in radians. We know it's between 0 and 200. 0 is less than x, which is less than 200. So it's got to be x is equal to 200 on 3. So that's what this value here is. Therefore, distance swum is 200 on 3 minus 50, which is 150 on 3, which is 50 on 3 meters. On another recommendation, the swimmer swims the minimum distance from the point P to the north bank of the river. Find this minimum distance. So the minimum distance is going to be when they're perpendicular. Let's just use a distance formula. So we know we've got the point P, which is 30, 50. We've got the other point on the other side. That's the point X. The north one is f1 of x. The distance is the square root of f1 of x minus 50 squared plus x minus 30 squared. So now we can just say the distance of f of x minus 30 squared plus x minus 50 squared, is that right? Other way around, you dumbass. 50, far out. 50, 30, and we want to find when that's a minimum, so calculation f min. We know it's between like 0 and 100. Okay. Have I stuffed something up here? F of x minus 50 squared, x minus 30 squared, because it's got to be bigger than that. Like, that doesn't make sense. F of x minus 50. Let's get rid of that. Is f of x correct? I've definitely got them around the right way, haven't I? 50, 30. I've got them around the wrong way. I was right the first time. 30, 50. Now let's try it. 30, 50. What? The hell is going on? We want to find when the distance is a minimum, because that all looks right. F min let's try it between 0 and 100 now. Okay, that's better. So let's say that the distance is 8.47 meters. So the distance is 8.47 meters. Now the reason that makes sense is because if we know it's 10 meters that way and 10 meters that way, that distance there, we could have just used Pythagoras if we wanted to, but it's much easier to do that. Calculate the surface area of the river shown on the graph on page 16 of the section of the river shown on the graph on page 16. Okay, so that's just the area from, oh, we just need to work it out. We don't actually have to do that. So we're going to go from 0 to 200 of our higher graph, f of x, minus our lower graph, g of x, dx, 2,000 meters squared. Horizontal line is drawn through the point P. The section of the river that's south of the line is declared a no swimming zone. Find the area of the no swimming zone. So there's our line. This area is a no swimming zone. Okay. What's the easiest way to do this? We could use that 2,000 and subtract that area and subtract that area. That might actually be easier. Is it hard to work out what that point is? So if we did this one, if we did from 0 to 50, and then we times it by 2, we know that area there is 1,000, and that area there is 1,000. So we know the area is 2,000 minus 2 times from 0 to 50 of f1 of x minus f2 of x dx. Is that what they called them, f1 and f2? Yep. And then we also want to subtract from 50. We worked out what that other value was before when we did the horizontal distance. Oops. So the horizontal distance is 50 on 3. It's 200 on 3. Because remember we found it in the last question. And then we do the graph of f1 of x minus the graph of 30 and times that by 2. f1 of x minus 30 dx. And that should give us the area of the shaded region. So let's say 2,000 minus this minus, it's effectively similar to that, but it's 200 on 3. And then f of x minus the graph of y equals 30. That's our exact answer. Now that doesn't look correct, does it? That shouldn't be 0, that should be 50. That looks like it might be better. So 837.25. Nearest square metre, 837 metres squared. So all we did, we know the full area is 2,000. We just found this area here, and then we doubled it. Which hopefully makes sense. Okay, scientists observe that the north bank of the river is changing over time. It's moving further north from its current position. Their models predicted the new location using the function y equals k times f1 of x where k is greater than 1. Find the values of k for which the distance north across the river for all parts of the river is strictly less than 20 metres. So if we think about it, f1 of x, k times f1 of x is 20k cos of pi x on 100 plus 40k, and we know f2 of x is 20 cos pi x on 100 plus, I think it was 30. Okay, So if we do f1 of x minus k times f1 of x minus f2 of x, we subtract those, so 20k minus 1 cos of pi x on 100 plus 40k minus 30. We want all parts of the river, the distance to be less than 20 meters. We know the maximum distance is the center of the graph plus the amplitude, and we want it to be less than 20, and we know that k is positive, so it can only go upwards, it can't go, it's greater than 1, so it's got to get further away, it can't get any closer. So we know 40k plus 20k is 60k, and then I've got minus 50 has to be less than 20, 60k has to be less than 70, k has to be less than 7 on 6. So if k is less than 7 on 6, and it's also got to be greater than or equal to 1, because they told us that in the question. So we know the function's got to be between 1 and 7 on 6 for this function to stay within 20 meters. Now if we have a look, if I said k times f of x, k is 2, that's too far away, k is 1 is there. If I make it go up by 0.1, that's 1.1. So you can see it's getting further and further away. It looks like it would be about, actually, we could do k of f of x minus g of x, sketch it, and we want to make sure that it's always less than 20, the difference. So you can see there's 1.1, it's less than 20. There's 1.2, it's greater. 7 over 6 must be less than 1.2, and it is. So that's going to be the right answer. Okay. A transport company has decided to record all of its deliveries. The number of minutes a delivery is made before or after the scheduled delivery time can be modelled by a normally distributed random variable t with a mean of 0 and a standard deviation of 4. Okay. If the probability that t is less than a is 0.6, find a to the nearest minute. So we want to find the area is 0.6 to the left, the standard deviation is 4 and the mean is 0. So A is 1 to the nearest minute. Find the probability correct series of a delivery being no later than 3 minutes after its scheduled delivery time, given that it arrives after its scheduled delivery time. So we want to know x is normally distributed with a mean of 0 and a standard deviation of 4. The probability that x is no later than 3 minutes, given that it's after its x is less than 3, given x is greater than 0, which is between 0 and 3, over the probability that it's greater than 0. So we've got to use continuous from 0 to 3 with a 4. And then we've got to go from 0 to infinity. So it's going to be that divided by that. 0.5467. So 0.547. Okay, using the model described on page 9 to describe the transport company can make 46.48% of its deliveries over the interval -3 to t. It's improved delivery model with a mean of k and a standard deviation of 4 minutes. Find the values of k correct to one decimal place so that 46% of its deliveries are between that. So we could say, let's call it I for improved. I is normally distributed with a mean of k and a standard deviation of 4. The probability that -4.5 is less than t, which is less than 0.5, is equal to 0.4648. Therefore, we know that if we find the area from -4.5 to 0.5, I think it was, and the standard deviation is 4, and the mean we're going to call it x, we know that's equal to 0.4648. We can solve for x. What's wrong with that? I've got an extra dot there. So x is negative, so our mean is -2.5 or -1.5. Find the values of k. So k is -2.5 or -1.5. A rival transport company claims there's a 0.85% probability each delivery it makes will arrive on time or early. Assuming whether the delivery is on time or earlier is independent of other deliveries. Suggest binomial. And then this is P. Assuming the rival company is true, find the probability on a day in which the rival company makes 8 deliveries, fewer than half of them. Okay, so let's say D for delivery is binomially distributed with 8 deliveries and a 0.85 chance of being delivered on time. Few of them, half of them, arrive on time or earlier. The probability that D is less than 4, which is the probability that D is less than or equal to 3. So we use binom CDF between 0 and 3 out of 8 trials and 0.85. So 0.00285. 0.00285 is 0.003. Okay, so I'm pretty sure that's right. Assuming the rival company's claim is true, consider a day in which it makes n deliveries, expressed in terms of n the probability that one or more deliveries will not arrive on time or earlier. So here, D, well, let's call it T for true. T is binomial with an n, and a 0.85, that one or more of the deliveries will not arrive on time. So we want 1 minus the probability that they all arrive on time. So it's 1 minus the probability that they all arrive on time. That's it. Hence or otherwise, find the minimum value of n such that there is at least a 0.95% probability that one or more deliveries will not arrive on time or earlier. So 1 minus 0.85 to the n is less than, is at least 0.95. Minimum value. Okay, so we say 1 minus 0.85 to the power of x is greater than 0.95. So x has to be greater than or equal to 18.43. Greater than 18.43. Therefore, the minimum is 19. So they've got to deliver at least 19 times. For the probability, there's at least 95% that one or more deliveries will not arrive on time or earlier. And because it's a minimum, we've got to round up. Okay. I heard the probability was hard, but maybe this is it. An analyst from a government department believes that the rival transport company's claim is only true for deliveries made before 4 p.m. For deliveries made after 4 p.m, the probability of a delivery arriving on time or earlier is x, and x is between 0.3 and 0.7. After observing a large number of rival companies' deliveries, the analyst actually believes that the probability that a delivery arrives on time or earlier is actually 0.75. Let the probability delivery is made before 4 p.m. equal y. Oh, Jesus. Okay, so they said the probability that it arrives on time is 0.85. They're saying this is only true for deliveries before 4 p.m. So we can say the probability that it's on time, given that it's before 4 p.m, is equal to 0.85. For deliveries made after 4 p.m, the analyst believes the probability of delivery arriving on time is x. So the probability of on time, given that it's after 4 p.m, is equal to x. And we know x is between those values. That must be significant later. After observing a large number of rival companies' deliveries, the analyst believes that the overall probability that a delivery arrives on time is 0.75. So the probability that it's on time is 0.75. Let the probability that a delivery is made after 4 p.m. be y. So the probability that it's after 4 p.m. is y. So the probability that it's before 4 p.m. is 1 minus y. Assuming that the analyst's belief are true, find the minimum and maximum values of y. The probability that it's on time is the probability that it's on time, given that it's less than that it's before 4 p.m, times the probability that it's before 4 p.m, plus the probability that it's on time, given that it's after 4 p.m, multiplied by the probability that it's after 4 p.m. Total or probability, I think it's called. The probability of A is the probability of A given B times the probability of B plus the probability of A given B naught times the probability of B naught. Okay, so let's sub in what we know. 0.75. On time and less than 4 p.m. is 0.85. Less than 4 p.m. is 1 minus y. Plus, on time and greater than 4 p.m. is x. Greater than 4 p.m. is y. Find the minimum values of x and y. Okay, so let's just sub in 0.75 equals 0.85 times, was that y or 1 minus y? I think it was 1 minus y, plus x times y. So this gives us a function that we're going to solve for y. So y is equal to 2 on 20x minus 17. Okay, so we've got to find the minimum and maximum values of y. And we know 3 on 10 is less than or equal to x, which is less than or equal to 7 on 10. So let's sub it in. If I sketch this graph, was it 2 on 20x minus 17? And we only want it between 0.3 and 0.7. Did I stuff it up? There's a negative out the front. Okay, that makes more sense. Negative. Okay, now when I sketch it, you can see it's an increasing function. So the min y min occurs at x equals 0.3 and the y max occurs at x equals 0.7. So now, given x is 0.3 and 0.7, 2 over 11, 2 over 3. Frickin' hell, that's a lot of a question for 2 marks. It's a lot of crap. Okay, question 4, and there's 5. This feels like it's taking a long time. Alright, let's clear all of this. Clear all of this. It's Saturday night, so I might be lagging a little. 2x. 2x times e, was it 1 minus x squared, to the 1 minus x squared. I'm going to define it as f of x. Let's go in and sketch it to make sure it looks the same. And let's have a look. It's only defined between 0 and 3. Find the slope of the tangent of f at x equals 1. Slope. Since when have they used slope instead of gradient? It's bloody stupid. Okay, so d dx, we're not doing further, and we don't really refer to slope unless it's a slope of a tangent. At x equals 1, it's -2. So f dash of 1 is -2. Find the obtuse angle that the angle of the tangent at x equals 1 makes with the positive direction of the horizontal axis. So we know the gradient is -2. So tan, make sure your calculator is in radians, no degrees. Tan of -2 tan inverse, you dumbass, of -2. Okay, so that's our angle, but you want to find the obtuse angle, so it's 180 minus that. 116.565, 117 degrees. Find the slope of the tangent of f. I don't like using the word slope. So f dash of p, let's try that. So d dx of f of x given x equals p. Jesus. Got the given. Okay. Negative 4p squared minus 2 e to the, I'm guessing it's 1 minus p squared, because it's the derivative. Oh no, it's going to be a, we'd have to use the product rule. Luckily the CAS did it for us. Find the value of p for which the tangent of f at x equals 1 and the tangent of f of x equals p are perpendicular to each other. Give your answer correct to 3 decimal places. So f dash of 1 is -2. Therefore, f dash of p is perpendicular to that, which is a half. Find the value of p. So we want to find when this is equal to a half, and it's set to decimal places. I want to solve for p, not for x. Okay, so p is -0.655, and p is equal to, however, give your answer. And x is equal to p, so p must be between 0 and 3. So we can say, however, 0 is less than p, which is less than, is it equal to 3? So p is only equal to 0.655. Hence find the coordinates of the point where the tangents of the graph at x equals 1 and x equals p intersect when they are perpendicular. Give your answers correct to 2 decimal places. So we can say the equation of the tangent at x equals 1, and then the same 0.655 Okay, so the equation of the tangent at x equals 1, we just say tan line at the point 1 is negative 2x plus a quarter. If we do the same thing, but this time we do it at that value, So we get a half x plus 1.99. I think it was 1, 1, wasn't it? 1, 2. So we let the tangents be equal. Therefore, we get that is equal to that. Solve it for x, 0.8035. To 2 decimal places, it's 0.80. And then we can sub it back into that to find out what y is, 2.39. So the coordinates are 0.80, 2.39 to 2 decimal places. Okay, two line segments connect the dots 0, f of 0, 3, f of 3 to a single point n, f of n, where 1 is less than n, which is less than 3. Sorry, I had to have a drink. Okay, the first line segment connects 0, 0, and n f of n, where n is between 1 and 3. Find the equation of this line in terms of n. We know the y-intercept is 0. The gradient is f of n minus f of 0, which is 0. F of n must just be this with an n substituted in. So we get 2n e to the 1 minus n squared over n minus 0, which is just n. They cancel. So we get y is equal to 2e to the 1 minus n squared x. We could test it on our calculator. F of n minus 0 divided by n minus 0 and 2e then multiplied by x, because we know that we've got no intercept, but that's the gradient, so it's the gradient times x plus c. The second line corresponds to n f of 9 and the point 3 f of 3. Okay, so here the gradient is f of n minus 0 over n minus 3. So that's our gradient. And we know that times x plus c is equal to y. If we want to find the equation of the line, we know it passes through 3, 0. So we can let x equal 3, y equals 0, and then we can solve for c, because we need the x and the y-intercept. Okay, this isn't very nice, but so we've got 2n e to the negative n squared plus 1 y is equal to 2n e to the negative n squared plus 1 x both of them I saw were divided by n minus 3. And then I've got negative 6n e to the n squared plus 1. Negative 6n e to the n squared plus 1. So you can see here, we can take out 2n e to the negative n squared plus 1. And we'd end up with x minus 3. Okay, find the value of n where 1 is less than n, which is less than 3, where there are equal areas between the function f and each line segment. Give your answer correct to the nearest 3 decimal places. So the first thing we know is this first area is from 0 to n. Is it called f of x? F of x minus my tangent, which is 2e to the 1 n squared, negative n squared, plus 1 dx. That has to be equal from n to 3 of my tangent minus my graph. So 2n e to the negative n squared plus 1, x minus 3 over n minus 3 minus f of x dx. Okay, oops, did I forget an x? Alright, so our first function is the integral from 0 to n of f of x minus that tangent, which is that, times x dx, and we know that's equal to the integral from n to 3 of that times x minus, I've got two minuses there, get rid of that one. So that's the other equation of the tangent, and then minus f of x dx. And then we want to solve for n, because that's going to be the point that makes the two equal. Frick. Solve for n. Now n had to be between 1 and 3. Ah, you stupid idiot. 1 is less than n, which is less than 3. .087. Now what that would mean, was it 1.087? Yep. What that would mean is if I found this area and substituted in n, found this area and substituted in n, they should be the same. Should I do it? Okay, grab this. Say given n is equal to this. Put it as a decimal, 0.89999. Then do it with a second equation. And do the same thing. Given n, same area. So we know we've done it right. Okay, finally, question 5. Let this be x cubed minus x G of A is the function representing the tangent to the line f at x equals A, where A is any real number. Let B be the x-intercept of the graph. Show that B is that. So can we find the tangent on the cas or not? What a pain in the ass. F dash of x, 3x squared minus 1. F dash of A, 3a squared minus 1. We know f of A is a cubed minus A. So the equation of the tangent (13 marks), so this is going to be a decent bloody question. y2 minus y1 is equal to m x minus, what's x? A. So we get 3a squared minus 1 x minus 3a cubed plus a cubed, and then that's going to be plus a, so when I bring it to the other side it becomes minus a, so they cancel. So y is equal to 3a squared minus 1 minus x minus 2a cubed. Let x equals 0, y equals 0. X is equal to 2a cubed on 3a squared minus 1. Therefore, b is equal to 2a cubed on 3a squared minus 1. Take the values of a for which b does not exist. Well, the bottom can't be 0. So let's get rid of all this crap. X cubed minus x. How did I get an I there? Define it as f of x. Find the equation of the tangent at A. I just defined it, didn't I? Calculation line, tan line. At the point A. Simplify. What did I want to do? We know that equals 0 and we want to solve for x, which is what we've just done. We know the denominator can't equal 0, so we set it equal to 0. Solve for A. And get our exact answers. A is plus or minus root 3 on 3. State the nature of the graph of that when A doesn't exist. At those points, there must be no intercept, so that's got to be a horizontal graph. So, f dash, take the nature of the graph. G of A, G dash of A equals 0, i.e. it's a horizontal graph, line. That doesn't intersect the x-axis. State the values of A for which B is equal to 1.1. That's B equals 1.1. Ish, that's horrible. Whoa, there's a lot. Okay, 4 decimal places. A is equal to negative 505, I think I saw. 2. (8084). 1.3468. Is that right? Did I miss any? Okay, so there's three values where it equals 1.1. The graph of f has an intercept at 1, 0. State the values of a for which 1 is less than or equal to b, which is less than or equal to 1.1. So 1 is less than or equal to b, which is less than solve for a, .8084 is less than a, which is 1.3468. Why do we have a solution here? So it's got to be between 1 and 1.1. Let's sketch this on our CAS. Make that an X. Make that an X. And we know it's got to be between 1.1 and 1. So there's something dicey going on there. Because that's the range that we found, but what about this one here? Let's find the intersection of blue graph and red graph. Blue graph and red graph. So that's negative 5.502, and that's equal to 1.1. Negative 5.5052. It can't be equal to because that's 1.1. But then if we find the other intersection point, negative 0.51. So we know there's 2. But when we solve it in the main screen, it didn't give us that. What about if we solve it on the other CAS? Menu 3, 1. And what was it? 2, no. 1 is less than or equal to 2a, the hell was it? 2a cubed on 3a squared minus 1. 2a cubed on 3a squared minus 1, which is less than 1, comma, a. 1.1 will help. Okay, so that gives you both. That's bullshit. That sucks. So if you were using this CAS and you didn't recognize this from the previous answer, you're screwed. Oh well. So there's going to be a lot of kids who get this answer. I don't know how they're going to mark it, if it's worth 1 mark and they get that. Let the coordinate B0 is the horizontal axis intercept of G of A, and G of A is the tangent. Let G of B be the function representing the tangent of the graph at x equals B, as shown below. Find the values of A for which the graphs of G of A and G of B, where B exists, are parallel and where B doesn't equal A. So we want the equation of the tangent at A, and then we want the equation of the tangent at B. I won't clear that. So if I say f of x, what do I just do? Calculation line, tan line, at the point A, we get that. Then if we do the same thing, but then this time we want to find it at the point B, which we know is that point. Oh, that's messy. Okay, so here we've got negative 2a cubed, we've got 3a squared minus 1 x and then minus 2a cubed. And then the equation of the tangent at B is 3b squared minus 1x minus 2b squared, where b is equal to 2a cubed, just because I can't be frigged writing out that other thing, on 3a squared minus 1. Let's call that y of b and call that y of a. Therefore, y of a equals y of b gives, if we let that graph equal that graph, we solve for A, whoa, so they've just got to have the same gradient that's parallel. So all we care about is the gradient. We don't need the equation of the tangent, you dumbass. Okay, so we can say f dash of A is equal to f dash of B. Therefore, have we found f dash of A? 3a squared minus 1. F dash of B of f of x given x equals, where'd that value go? That one. I think I like the first one best. 12a to the 6 over 3a squared minus 1 squared. And then the last bit, minus 1. A is equal to that equals, where's the other one? Three a squared minus 1, I think it was. solve for A. A is -1, 0, 1, plus or minus root 5 on 5. Okay. If we know, I reckon they're going to have to exclude some answers. If we know A is 1 and B is 2, what the hell is B again? 2A cubed on 3A squared minus 1. We've got to see if A and B are the same point. So, we know B is that. If we say given A equals 1, B is also equal to 1. If we say given A is 0, B is also equal to 0. If we say A is -1, B is also -1. In this case here, A equals B. Therefore, A is equal to plus or minus root 5 on 5. Because we can't have those values because it says B can't equal A. Okay, let P equal, for all real values, x cubed plus wx. W is an element of R. Show that P of -x is equal to negative P of x. P of -x is -x cubed plus W times -x, which is -x cubed minus wx, which is negative x minus plus wx, which is negative P of x. So if we reflect it in the y-axis, it's the same as reflecting it in the x-axis. A property of the graphs of P is that two distinct points, parallel tangents, will always occur at T, and negative T and P of negative T. Find all values of W such that the tangent of the graph at T, for some T is greater than 0, will have an x-intercept at negative T, 0. So, find all values of W such that the tangent to the graph at P, for some T is greater than 0, will have an x-intercept. So let's just find the equation of the tangent of f of x at the point T. Okay. So that's our equation of the tangent. We'll have an x-intercept at negative T0. So we can say the equation of the tangent. Oh, what the hell? I'm not even going to write that. Can't be bothered. So that's the equation of the tangent. It's got to have a, when y equals 0, x has to equal negative t. So if I find the x-intercept of this, I get x as that, and we want it to equal negative t. So t, what? Oh, frick. There's no w in this one. Okay, so we've got to do it all again. But the first thing we want to do, we want to go back down here and define x cubed minus w times x. Define that as f of x. And then go back up and do it again. So we get this, then we want to solve this, and then we want to solve that. Where do we get w's? Is that right? I think I should just start again. So x cubed minus, is it minus or plus wx? I really need to go to the toilet, so I'm bloody hurrying. What the hell? Where is w? X cubed. Where the hell is the original equation? X cubed plus wx plus w times x. Define that as f of x. Find the equation of the tangent at the point something, at the point t. Simplify it. We know that equals 0. Solve for x. What do we want to solve for t? I'm just going to be back in 2 minutes. Okay. The only problem with the iPad is you can't pause this program. It either stops or it continues. Okay, so there's our function. That's our x-intercept, and that's got to equal negative t. So if we solve for t, we solve for w, because we're trying to find w, I think. So w is equal to negative 5t squared. Find all values of w such that the tangent t is greater than 0. If t is greater than 0, then w will always be less than 0. Because if you put t is greater than 0 in there, that's positive, which means that w is always going to be negative. So w has to be less than 0. State any restrictions on the value of m, n, h, and k, given that the value of p under the transformation t always has the property that parallel tangents occur at x of negative t and x of t for all t doesn't equal 0. Okay, so just so we have a graph that looks like that, m dilates it up and down, so that can be anything except for 0, because it's still going to have the same tangents at t and negative t. If we dilate it from the y-axis, it's going to become wider, but the same thing's still going to occur. So n can't equal 0. If we move the graph up and down, So if I keep the same shape, but move it up and down, there's negative t and there's t. That's still going to be okay for all values of h. No, k, because k is moving it up and down. H moves it left and right. So if I have a graph that looks like this, if I move it to the right, that value there and that value there are not t and negative t. They aren't correct. So k can be any real number. However, h is going to have to equal 0 because we can't move it left and right. We can move it up and down. We could dilate it from the x-axis and dilate it from the y-axis. So as long as they're not 0, that will be fine. And yeah, it won't make any difference with any of them. We know that h has to equal 0. It won't have that property. K, it can be moved up and down as much as you want, and it'll still have parallel tangents at negative t and t. So m is 0, and m can't equal 0, m can't. So we know they've said that in the question. M, n can be any real number except for 0, because then the function would disappear. H has to equal 0, and k can be anything you want it to be. I think that's what they want. State any restrictions. Yep. That's it. So that exam sucked. That was really long. This is ridiculous. 2 marks. Even this one, 1 mark. This for 1 mark. This for 1 mark. I'm guessing this is because it's the last 2 questions on the exam. But, yeah, that's pretty average. What else didn't I like? It was just long. I felt like, I mean, not many people would get that as well, I reckon. Not a big fan. I just think they're making them too long now. It's making it too hard to be able to do. Anyway, hopefully these solutions help the kids from following years. And hopefully you guys get something out of it, the kids who did it this year. I'll see you next time. Bye.